Hello and welcome to the Group 16 presentation. I'm Dylan Haruluk and I will be going over the building a message broker system. And specifically I will be going over the definitions and significance and the engineering and practice area of the project. So first off, I'll go over how Microsoft Teams was used. So the way in which me and my group used Microsoft Teams was we used it to communicate and meet virtually in a voice call to go over and disperse the responsibilities amongst ourselves. So we use that to log that, and then we log communications and any other questions we would have through there and in the future. And then also, we also used it to keep track of our meeting reports and our progress reports. And I have uploaded our first meeting report in there, so that should be visible currently. And now let's go over the definitions, overview, and significance of the topic. So first of all, we have to know what a message broker is. So a message broker is a software module that takes a message from the sender to the message medium and transmits it to the receiver. So essentially, it's like RabbitMQ is a message broker for Instagram currently. And then also we have message queue, which is the queue of the messages in which they get deleted once they're properly sent. And then we have routing, which is how the messages are actually sent and how the broker decides to send them and how to disperse them specifically and to how many people. So the general overview we can see is in a messaging model such as publish and subscribe, where multiple users can receive the same set and structure of messages. Also complex routing, which can change depending on which users or how many users are in a broker system, such as a publish subscribe system, APIs which can connect apps to the actual broker and thus connect users through there, and then reliability measures which can also make sure that messages are being sent, received, and optimally and efficiently. And also these brokers must be scalable given the potential user base as we've seen previously through Instagram. And then significance. So it is significant that the message brokers adequately follow these, where it allows for the sender and receiver to exist as two separate entities. So essentially it's like a mail list. The users can sign up and then the same user can sign up for a separate list. While the initial list still exists and gains new members, they still send to the original member and the new members. While the original member can sign up for new lists, so they both coexist, but they're both evolving entities. So they don't need to be tied to each other, but they just have to be related to each other in the sense of when they signed up and receive emails and or not emails, but any communications and send them. And then message brokers are reliable and will ensure the sending of a message despite deviations. So essentially, they have to ensure that communications are sent, because otherwise, how are you going to have big corporations and companies like Instagram relying on these brokers when their messages are not going to get received? Even if there's a delay or deviation, they have to be received. Message brokers can serve users on a wide range of communication patterns. So essentially, they can serve as a service that allows for requesting and replying style of messages, or one where an entity publishes content and the broker simply sends it out. So more like a newsletter or like a blog. And then also what's significant is anomaly and fault tolerance, where it will check and confirm messages and if they actually were sent, received, and then, okay, this is good to go. We're done with this message, like we previously talked about routing or message queue, where we'll delete that from the queue. Now let's look at the relevance to engineering design and practice. So the first main relevance I want to go over is reliability and anomaly handling, where the act and measures taken to ensure that the broker system will be resistant and resilient to anomalies and failures, which is crucial because reliability is necessary in these systems, especially when they're utilized in professional environments. This ties also into engineering design and practice, as ensuring these measures are met and implementing workflows and structures to ensure that itself are crucial, and only ways systems like this will remain reliable. So essentially we need to ensure that these message broker systems are staying consistent, reliable, and actually getting these messages across and receiving messages. Otherwise, they will never be efficient and never be adequate for professional environments and firms, and will just be obsolete. So, without this, they will not be where they need to be and will not be utilized at all. So, that's where the engineering and creation comes into play, where these developers have to properly tweak and tune these systems to coexist in these environments, like previously stated, not rely but coexist, and also serve all the other potential clients and firms they also have on the back end. So, also another important aspect of this is security and compliance, where in relevance to engineering design and practice, security measures and compliance checks are integral in building a message broker system, as data integrity and secure communications are necessary, especially in professional environments. It is crucial to ensure authorized users are the ones accessing delicate communications while also maintaining design systems that comply with regulations they need to be built upon. Building such a broker system would require careful analysis and consideration to ensure these are at least adequately met. So, along with these communications, you have to also make sure the right people are getting these communications and replying to them. You can't have someone that isn't supposed to receive something receive it and get valuable information, especially from private firms and government sector um, professional environments where this information could be very, very critical in the wrong hands. So you need to have some sort of validation for all this information and also be able to secure and encrypt this information as it's traveling so no one can take it from any means of hacking. So you also need to comply with regulations set by the government and any other companies, firms, any specific rules or compliance rules to follow. You need to always be adjusting and adapting to all this, and more in the future, where it's going to keep changing due to recent developments, especially in AI, cybersecurity. It's going to keep changing, and you got to keep adapting and updating, and have a solid team of software engineers working on this to make sure the broker system ties together perfectly along with all of this. So now I have some questions for the viewers, audience, regarding my topics I just went over. So the first one I would like to ask is, of the described attributes of a message broker system, which would you say is the most critical nowadays to ensure an efficient system? So the stuff such as reliability, scalability, security, which of those would you think is the most critical nowadays? Personally, I would say security, especially given the new attacks and AI coming out to look to exploit. And then we have, given the necessary attributes of a message broker system, how big of a team and how hard of a task would you say it would be to build such a system, especially given the way technology is evolving today? So, kind of piggybacking off the previous one, how monumental of a task would you think it is, especially with these new developments in AI and security coming out? Would it be to get a successful system like this implemented, and especially for the big boys like Instagram, like we just looked at? How hard of a task would you say that is? I would say personally that is a very difficult task, and you would need a really solid team behind that, all collaborating and all working good together. You can't just have anybody working on that. So that's how I would answer that. And now I'm going to hand it off. Thank you for that.
My name is Sakai Win. I'll be going over the applications and impact of message broker systems. Starting off with the applications, message broker systems are used in a variety of our day-to-day tasks. In social media, message brokers can be used to provide users live feed updates and personal messaging notifications. They can also track analytics for users to see their views and clicks on posts. Multiplayer gaming utilizes message brokers for chat messaging and leaderboard updates. Player statistics can be tracked and used for achievements and rank matching opponents. E-commerce and subscription services handle orders, payments, and subscriptions with message broker systems. They manage messaging to different payment gateways, and when subscriptions are made, content can then be sent off to subscribers. Now on to the impact of message broker systems. Message broker systems have made communication more reliable and flexible by accounting for larger loads with an increased scalability and handling protocol translations across different platforms. These systems also include features like asynchronous messaging and message retries. This means messages can be sent regardless of whether or not servers are online, and when a message fails to send for whatever reason, it can be queued for a user to resend or cancel. Overall, message broker systems are made simple so they can be reused for different producers' needs. My question for you is, how do real-time updates made by message brokers help your experiences as a user?
Hello, this is Assam Sadiq, and I'll be talking about the issues encountered in the engineering profession and potential solutions. First, I'm going to talk about scalability. So, here's an issue that comes up. When you have a message broker system, if you have a lot of customers, you're obviously going to be dealing with high volume sometimes, and it's going to slow down your system. And a potential solution to this is to use a database that can handle high volume like this, like MongoDB or Cassandra. Another solution is to use a compression algorithm on the data that's being sent to the database. When you use a compression algorithm, the data that's being sent is going to be smaller, and it can have more ease on the system itself. Another potential solution is to use a distributed message queue. This is pretty much just distributing the message queue across multiple servers, and this can help with scalability and to ease the servers altogether. So the issues encountered in the engineering profession and potential solutions, we're going to be talking about latency. So an issue that comes up is sometimes your messages can take a while to send, especially when the servers are overloaded. This is latency. And this kind of overlaps with scalability in a sense, because high server load can also cause high latency. A potential solution is to optimize the network itself using faster protocols. And going back to the previous slide, we also talk about using a compression algorithm. Using a compression algorithm can also reduce latency because the message is going to be smaller. And that would also improve the latency itself. Another solution is to use a cache. Using a cache, pretty much you load some messages on the client, so when they load up their app, they won't be getting the data from the server every time, and this can also help with ease on the server itself and improve latency. And the last one, we're going to be talking about security. Security is a very broad topic itself. When it comes to a message queue, and if you're a large company, you might want to have some API to maybe monetize off of. And API security is also very important because you don't want bad actors abusing your API and causing more load on the server, which can also cause higher latency. And there's also a lot of other issues that can come with it when it comes to security itself. So a potential solution for API security is we obviously want to authenticate properly the users, and you want to recommend them two-factor authentication, because you don't want some random person sending another person a message, because that's also a big security issue. What you can do is you can add an authentication system, and along with the authentication system you can implement session IDs. Session IDs is like a generated unique number from the server, and you want to assign it to the person that's logged in. So you don't want someone who's not logged in to send a message to someone else, because this is a vulnerability, and it can cause a lot of issues. Another solution we can add is you want to use encryption where necessary. Encryption is necessary because this will protect your data from unauthorized access from bad actors. And the last solution is we always want to implement server logs, because if you're not implementing server logs and your server gets attacked by a bad actor, you're not going to know where to trace it from. So adding server logs where necessary, like when somebody sends a message, someone logs in, someone logs out. This is very important to keep track of what's going on in your system, and it can help track down the issue and mitigate it in case there's a bad actor. And finally, I'm going to ask a question for the audience. So we've discussed some of the basic issues encountered when trying to implement a message broker system. We talked about scalability, security, latency. So what are some other issues that might potentially occur? I think some issues can occur with networking, maybe, and that's for you guys to decide.
Hello, my name is Akina Williams, and I'll be presenting the two topics that I covered, which were the ethical issues for message broker systems and some challenges and opportunities associated with such systems. The first ethical issue would be data security. This is one of the most important jobs of a message broker system, and it is to ensure that data is transferred from one user to the next securely. The use of data encryption tools is employed to ensure that during transmission and delivery, the data does not end up in the hands of unauthorized users. An example of this would be an IT department employee at a bank gaining access to millions of customers' social security numbers during routine operations on the message broker system. The next one is data integrity. A primary service of message broker systems is to make sure data integrity is assured. This means that whatever is sent through the system is received by the end user accurately in its entirety consistently throughout the usage of the system. Inaccurate information can be avoided by deploying tools that ensure input validation and error detection. Accurate data is especially important in the fields such as credit scoring to ensure fair and bias/wrong data processing. And then there's the consent of consumer. Customers of a business should be informed when their data is being collected and what it will be used for to ensure full transparency throughout the process. It is also extremely important that they are aware of all parties who will have access to this information. And then we have the challenges such as scalability, efficiency, data theft, and compliance with regulatory boards and consumer protection laws. For scalability, as a business grows, the message broker system will be processing and transmitting a larger quantity of data. So we have to make sure the system has proper load balancing and consistent maintenance to keep up with the client's needs. Efficiency. A message system has to be efficient not only in its message delivery time, but with minimal latency and cost-effective overhead. The system should also be efficient in managing memory resources, especially when handling a large amount of data. Data theft. There should be measures in place to prevent data theft from unauthorized users, such as hackers or malicious insiders, from infiltrating our system and stealing clients' information. And lastly, we have compliance with regulatory boards and consumer protection. There should be periodic audits of the system to make sure it is compliant with regulatory boards and a variety of different industry standards such as HIPAA, which is the Health Insurance Portability and Accountability Act, which is used by hospitals all over the country. And there is also FIPA, which is the Florida Information Protection Act, which is used in Florida, obviously. And lastly, we have opportunities. And these opportunities will consist of security, growing market, and integration. For security, by prioritizing security, we can deliver a safe and reliable system to businesses and build an overall good reputation. There is also the opportunity to analyze previous system failures from other rival message broker systems and learn from them. Growing market. The amount of available data is growing at an exponential rate since 2020, and with the advancement of new technologies in AI and increase in IoT, which is the Internet of Things technologies, this will boost the growth rate even more. And lastly, we have integration. With physical storage being limited, This presents an opportunity to integrate our message broker system with cloud platforms such as Google Cloud or AWS, which is from Amazon. And while integrating our system in different IoT environments, this presents us with the opportunity to manage data more efficiently. And one question that I had related to this topic was, based on what we just discussed, what are 3 ways you think message broker systems impact your everyday life?